Hello everybody and welcome back to my channel. So in today's video we will be going to see how we solve recurrence relations. Now in the previous video we saw how to write the recurrence relations. So in this video we are going to solve it using three methods. Now the first is substitution method. It is a little bit a long method but it gives you several informations about the recurrence relation. Now the second is recurrence tree method. We use this when we have more than one calls and both on all of the calls are of different nature. The last is a mathematical way of solving a recurrence relation, which is using Master's theorem. Now in today's video we will be going to see only substitution method. In the upcoming videos we will be focusing on these two. Now let's start with this. Now see, in this recurrence relation, the main answer will be dependent upon this part. So let's just write it over here. So Tn is equals to Tn minus 1 plus order of 1. Now if I just replace n with n minus 1 in this whole equation, so the equation becomes Tn minus 1 is equals to Tn minus 2 plus order of 1. Now what I can do is I can substitute this value over here in this part. So this becomes T n minus 2 plus order of 1, this is for this part, and plus order of 1, which is this one. So I can write my Tn as this. Now if I substitute n is equals to n minus 2 in this equation, so I get Tn minus 2 is equals to Tn minus 3 plus order of 1. Now putting this value over here, I get Tn minus 3 plus order of 1 plus order of 1 plus order of 1. So I can write this as Tn minus 3 plus thrice order of 1. Now what you can see is that in first step I had this equation. In the second step we got this equation. And in the third step, we got this equation. So what I can do is, if suppose that my algorithm terminates after k steps. So what I can write is, I can write t n minus k plus k times order of 1. So this will be the equation that we will receive after k steps. And now if I say that after k steps, my algorithm will terminate, basically it reaches the base condition. So this value has to become 1. So what I'll say is n minus k will become 1 and hence k is equals to n minus 1. So this is the condition that will be achieved in order to terminate my recurrence relation. So over here I'll replace k with n minus 1 and hence I'll get t1 plus n minus 1 times order of 1. Now T1 is nothing but order of 1, so this becomes order of 1 and hence I can write it as n times order of 1. And this is nothing but n times a certain constant, then I can write it as order of n. Now see, any recursive function which has this recurrence relation for anything, for maybe for time or space or swaps or comparisons. So this recurrence relation shows a linear property and it works in order of n. Now see what all things my substitution method can help me derive. Now first of all, we can derive the height of our recurrence tree. Now see, the height of a recurrence tree depends where my base case is achieved. So over here we just saw that when my k is n minus 1, that is for n minus 1 steps, after n minus 1 steps my base case is achieved, hence n minus 1 is the height of my recurrence or recursive tree. The second thing that we see is, now see over here we got this as our answer, but in the upcoming examples you will see that the answer will have many terms such as n square plus n minus n by 2 and so on. So what this tells is this substitution method doesn't just give us the dominant term, but it also gives us the other terms. So substitution method gives us a more precise answer uh, in comparison to the other two techniques. When we talk about these two techniques only give me the dominant term so that I can write it as order or theta or omega. Like over here, this gn is given, that is the dominant part of the function is given. Now let's look into the second example. Now in this example, the main part is Tn is equals to Tn minus 1 plus order of n. Now replacing Tn as Tn minus 1, so I'll just write it directly over here. So here we'll get Tn minus 2 plus n minus 1 plus n. So I'm not writing order again and again. I'll just simply write them like this. Now if I substitute the value over here, so I get is n minus 3 plus n minus 2 plus n minus 1 plus n. Now see, after k steps, what my equation will look like? My equation will look like this: Tn minus k plus, I'm just writing it like this, plus n minus 1 plus n minus 2, and we are going to do it till n minus k minus 1. Okay, so now in order to terminate this part, we need to make this value as 1. So n minus k should become 1, and hence k becomes n minus 1. And if I just replace k as n minus 1 in this equation, so the thing that I get is this will become t of 1 plus n minus 1 and so on up till, if I put n minus 1 over here, so this becomes n minus 2, and n minus 2 is 2. And T1 is nothing but order of 1. So what I can do is I can write this order of 1 over here. And now this is nothing but summation of n, and the value of summation of n is n into n plus 1 by 2, which is n square by 2 plus n by 2. Hence, a more precise answer to this recurrence relation is this, but we can say it as order of n square. So any recursive function having a recurrence relation, this shows that it works in order of n square, and the height of the recurrence tree will be of size n minus 1. Now let's see this example. Now in this example, this is same as the previous one. The only difference is instead of plus, we have a multiplication sign over here. So we have Tn is equals to Tn minus 1 into order of n. Now if I substitute a value over here, so we get Tn minus 2 into n minus 1 into n. This n comes from here. Now in the third step, we get Tn minus 3 into n minus 2 into n minus 1 into n. Now from this step, you must have noticed how our recurrence relation will look like after k steps. So after k steps, we have n minus k into, now if I write it like this, so n into n minus 1 into n minus 2 and so on into n minus k minus 1. Now we will be putting this as 1, in order to achieve a base case, and over here we get n minus k is equals to 1, and hence k is equals to n minus 1. So when I replace k with n minus 1 in this equation, so what I get is t1 into n into n minus 1 into n minus 2 and so on into 2. Now see, this t1 is nothing but n. So what we can write here is n into this. Now this whole is nothing but n factorial. So this is n into n factorial. So the exact answer to this is order of n into n factorial, or you can also write it as order of n to the power n plus 1. This is a more tighter answer, but even this is a correct answer. Now let's see the next question. Now in this question, what we see is that my n is getting divided by 2 in every step. So the first step that we have is Tn is equals to Tn by 2 plus order of n. Now when I substitute value for this particular term, so we get Tn upon 2 square plus n by 2, and then this comes down as n. Now let's substitute the value for this again. We get Tn by 2 cube plus n by 2 square plus n by 2 plus n. Now over here you can see when I will write it in terms of k, so we get t n upon 2 power k. That means after k steps we are going to achieve this equation. Plus, now I'm going to write it in this fashion, so this becomes n plus n by 2 plus n by 2 square and so on up till n upon 2 to the power k minus 1. Now we have to make this as a base condition, so it will be 1. So over here we'll write that n upon 2 to the power k is equals to 1, and hence my k comes to be log n base 2. Now if I just simply replace k with log n base 2, so what we get is we get t1 plus n by 2 plus n by 2 square and up to n upon 2 to the power log n base 2 minus 1. Now see how we can solve this part. Now this part can be written as 2 to the power log n base 2 upon 2. Now we know that this and this can be swapped, so we get n log 2 base 2. Log 2 base 2 becomes 1, and hence this whole region becomes n. So the value for this, the denominator, is n by 2, and hence what we can do is we can just simply replace this denominator by n by 2, and hence this becomes as 2. Okay, and now we know that when my t is 1, it is order of 1. So over here this becomes order of 1, and I can just remove it from here and write it over here. Now this is nothing but a GP series. We can also see it in this fashion, that first it was 1, then it became 2, then it becomes 2 square and so on. And this is nothing but 2 to the power log n base 2, because for k this is done for k number of steps. So the equation that we have is 1 plus 2 square and so on up till 2 to the power log n base 2. Now see over here, what we can see is this is a GP series, and hence we can find the summation using the formula, which is the first term is 1, the common ratio is 2, the number of terms are log n plus 1, which is base 2, minus 1 upon common ratio minus 1. So this comes out to be 2 times n minus 1, and this is our answer for the equation, and this can be written as order of n. So if any recurrence relation has this property, so we say that it works in order of n and the height of the tree will be log n. Now coming to this last question, this is a very important question, so please pay a lot of attention on this question. Now in this question what we have is we have Tn is equals to 8 times Tn by 2 plus order of n square. So let's just write n square. Okay, now see we have to substitute over here. So in the next step what we'll have is this 8 will remain over here. We are going to substitute some value over here and then plus n square. Now see when we substitute value for this, we get 8 times Tn by 2 square plus n by 2 whole square. So what happens a lot of time is that generally people forget to multiply this whole by 8, and hence they end up getting a wrong result. So see what happens over here is when I open up this bracket, and we get is 8 square into t n by 2 square plus 8 times n square by 4. So this becomes 2n square plus n square. Now if I just substitute value over here, so what we get is 8 times some 8 square times some value plus 2n square plus n square. Now if I just write value over here, so what we get is 8 times tn by 2 cube plus n by 2 square whole square. And when we are going to open it, what we get is 8 cube tn by 2 cube plus 8 square times n upon 4 whole square. So what we can write it as 2 square n square plus 2n square plus n square. Now see, using this we can simply see what my equation will look like when I replace or when I write it in terms of k. So what we get is 8 to the power k into t n upon 2 to the power k plus, if I write it like this, n square plus 2n square plus 2 square n square, and we are going to do this up till 2 to the power k minus 1 n square. Now see, when our base condition is when n is equals to 1 and it is of order of n. So we are just going to put this as 1. So this becomes n upon 2 to the power k is equals to 1. Hence my k is equals to log n base 2. And over here what we get is 8 to the power log n base 2 into t times 1 plus n square. Let's just take n square common from all of these. So we get 1 plus 2 plus 2 square, and we do it till 2 to the power k minus 1, which is 2 to the power log n minus 1. And over here we have a base 2. Now see, this can be solved by swapping 8 and n. So we get log 8 to the base 2, which is 3. So hence we get this term as n cube. And we know that our base condition is takes order of n time, and then plus n square into this value. Now this value can be achieved using the GP series. So what we get is we get as 1, 2 twice, the 2 is the common ratio. Number of terms are log n base 2 minus 1 upon 2 minus 1. So this term becomes n minus 1. So our answer is n to the power 4. So our answer is n to the power 4 plus n square into n minus 1, which is nothing but n to the power 4 plus n cube minus n square. So our more precise answer is this, but we can say that this takes order of n to the power 4, and the height of the tree will be order of log n. So these were some examples which we just solved using the substitution method. And now after solving these examples, you must know why we call it substitution method, because for every step we substitute the value using our main equation and then we find our answer. So this was all about substitution method. In the next two videos, we are going to see what is recurrence tree method and master's theorem. So stay tuned, and if you like my video, do subscribe to my channel. Also spread it with your friends. Thank you.